Good afternoon to one and all present here. I hope everyone is doing well. It is indeed my great pleasure to welcome among us the alumni of university and founding member of SAE India JVT Club. Not only it is a moment of happiness for us, but also an opportunity to reflect on our learnings and achievements. On behalf of SAE JVT India, I would like to welcome Mr. Rajat Bisht, ex-maintenance engineer in Adani Wilmar Limited, and one of a remembered and honorable alumni of our university. Now I would like to hand over the presentation to Rajat sir. Sir, to you.
You, the SAE members, the SAE office bearers, and the faculty members involved. It's really a good thing that they have started to interact with the young students over there. So today I'll be starting with my session. Today, basically, it is a session regarding how to become industry ready. Like most of the people over here are almost at third year or fourth year, or I'm not even third year or fourth year. Any of the student who wants to go into the industry right now, I'll be just giving you my preferences or my opinions regarding where you should go, what path you should follow in order to reach a particular industry. This won't be a overview of all the things. I won't be going into any much deep of the things that are involved in here. I'll be just giving you the brief overview, what the industry is expecting from you, what the industry is demanding from you. So today our focus will be on becoming industry ready. I'll be just giving you the overview of what is expected of you as engineers. Right now, as you know, the students they have a different mindset, but the industry is expecting out of them. They are having a different mindset. So I'll try to bridge the gap between these two. So my presentation will be mostly of three parts: my experience, what I think the industry demands are right now, and what is your role. How can you become industry ready? So I'll be starting with my experience, how my journey has been to the industry, how I started, what have I done in order to reach over there. So the first is I have studied mechanical engineering from JP University of Engineering and Technology, Guna, and I have passed out in 2019. From the starting itself, I had been very much interested in motorsports and automobile. And right from the childhood, uh, my dream has been to become an automobile engineer. So that has, pushed me toward more towards mechanical engineering, pursuing mechanical engineering. So my journey into motorsports at national level started from participating in national level competitions. The college team was known as Arden Clan Motorsports. In the first year, I was involved with the team right from the first year. In the first year, I was a member of the team. I had to go for an interview. We had participated in a competition in Gautam Budh University in Noida. The competition was called Off-Road Battle. It was a single Baha type buggy. For the second year, I was involved in the designing of a go-kart for NKRC, but that was not the competition that year. We had just done the design part. And also, I was also involved in Solar Vehicle Challenge, ESVC. It was organized by Imperial Society of Innovative Engineers. So I was also involved in the designing part. In the third year, I was captaining the university team. So for that year, we participated in Rally Car Design Challenge. It was first time in India that a two-seater segment competition had been introduced. Before that, only as many of you might be knowing, Baha is a competition in which we used to race these single-seater buggies, and also other small competitions that too involved this only Baha buggies, a single-seater buggy. But Rally Car Design Challenge was more into two-seater segment. In the fourth year, I was the principal advisor of the team. For that year, we had also won a podium position in the same competition, RCDC. MES and SAE has been a vital part of my journey in JUET. I was involved in MES right from the first year, Mechanical Engineering Society. Uh, they gave me an outlook towards other things that can be done rather than academics. the extracurricular activities that had to be done, various exposures, interaction with various seniors was due to MES only. So that has also been a quite a important and a crucial role in my life, because that pushed me towards more towards participating in activities. SAE was a turning moment in my career, I would say, because in SAE, I was in third year, I guess. Yeah, I was in third year, and in SAE, I had to. Uh, we formed the club. We got to know more about the organizational sides rather than the technical sides. So, my small, what would you like to say? My small info to you guys would be only this, that not only in the technical, you guys should also participate at such a level where you get to know more about the organizations, because many industries sometimes say that the people are having the technical skills, rather they do not know how to work in an organization. So if you participate more in these type of competitions and be a part of society, so you get to know that moral values and the team values that there are, and how the organization works, the hierarchical structure and all the different departments that come together. I had also written research papers in my college days. In my bachelor time, I have written 5 research papers. Under the guidance of Dr. Dhananjay R. Mishra. So this has also been, you know, pushed me towards more towards the technical side, how to get involved into more research-based activities rather than just the, uh, textbook things. So overall, I would like to say my college journey had involved each and every aspect as per my perception. I view it as a uh, wholesome curriculum for me also, and my overall development and growth had been due to these activities. Regarding my industrial training, so I had a chance to get myself trained into very good organizations. So first organization I was in second year. In my second year vacational holidays, I started to trained myself in HRTC, Himachal Road Transport Corporation. I was deputed at the district workshop powertrain department. So over there, I got to know the hands-on experience, as people say these things. The hands-on experience that has been more involved towards how the things that I did were different from the textbook. Like in textbook, if we are told that this is a piston, this is a crankshaft. So they over there, I got to see the internal particulates of the engine, how the things are there, right? So my more enthusiasm towards the automobile sector had been right from the HRTC, I would like to say. And in the third year, which was my main industrial training, I was with the International Center for Automotive Technology, Manesar, one of the brilliant and one of the finest institutes in India. It's second. It was earlier, I think, ARI Center 2, but now it has been given a name, International Center for Automotive Technology. Over there, I was under the guidance of Dr. UD Bangale. Due to him, I got the opportunity to work over there. Uh, I was deputed in engine test cell lab. My interest had already been in the powertrain sector. So engine test lab, cell lab provided me with various opportunities. Over there, I got to work with Volvo, Honda, Cummins, New Holland, Sonalika in all of their R&D departments. Since I was deputed as from the ICAT side, so I was into more into the development part, because the research department are solely based on the industries. Uh, I was working with Volvo Eicher for their first BS6 engine in India. So over there also I got to know more about the emission reduction part, and how we monitor the emissions. I was also introduced to various other companies which make brilliant machines regarding these only. Uh, so my typical day over there was just to be like, you guys might have seen dynamometers, as I would like to show you just a second. So this was a dynamometer and this was the engine. So my daily duty was to run different emission cycles. There are different emission cycles based on which we categorize them into BS6 engines, BS4 engines, BS3 engines, right? So I was working on BS6 engines, and this setup was by company AVL. So a dynamometer, we were running WHR, World Harmonized Transient Cycle over there. So these were the basic things that were involved. I was involved in. Okay. So I was given two opportunities when I was in my final year. Uh, my placement was in. I was placed in two companies. One was Sanmar International, and the second one was Adani Wilmar Limited. So I pursued to go into Adani Wilmar Limited because the profile suited me more. Adani Wilmar, most of you might be knowing, it is famous for the famous Fortune brand. It is one of the largest manufacturer of edible oils in India. Right now, they are also into uh, not only in edible oil but also in other food products. Now they are entering the FMCG industry. I was posted as a maintenance and utility engineer over there. I had worked in three locations pan India. One was in West Bengal, other two being in Gujarat. My final location was in uh, Mundra. It is the largest plant of Adani Wilmar. So moving on towards what are the demands in industry? What actually do you need to thrive in the industry? What industry expects of you, right? So before moving towards, I'll ask you a quick question. What is core? We have heard of this term that we have to go into core industry, we have to get core jobs. So I'll just like to briefly get to know your input. What is core? Any one of you can answer.
Sir, core industry is basically an industry where our knowledge of mechanical engineering, what we have studied in our BTech, that is applied in that industry according to our job profile.
Yes, yes, yes. You are quite correct. My friend here said that it is basically what you will be applying in the industry, right? So that doesn't mean that core industry only is for mechanical engineers or either for civil engineers. It's basically if you're a computer science engineer and you're working in a computer science company, that is your core industry. Now, what I would like to bring the attention is that there is a very slight difference between a core industry and a core job, right? All the time even when I was in college, I used to hear of this term that we need to get into core, we need to get into core. So I'll tell you what basically the core industry is first, okay? So the core industry is where you will have to be working with the core jobs, right? First, I'll come into the core jobs, and then this is the core industry part. Like the first is the core mechanical jobs. The thing that we have been, studying right from the first year, be it your solid mechanics, be it your material science, right to the final year where you are studying additive manufacturing and all those things. So these are the subjects that you have studied over there, and you would be using this on your daily terms, right? For example, the first one is the R&D sector. The R&D sector is basically the research intensive jobs, the design sector, the lab jobs, software companies. Now, research intensive jobs, like if you are a junior research fellow, or if you are working in research and development part where you have to test the various parts of a particular automobile or any particular product, design sector where you need to design things, not like I have sketched a thing or two. The design sector is where you need to do calculations which involves every subject like your dome, SOM, comb, and then applying it into a very engineered based product, right? The lab jobs are same, like the testing jobs you get to see. Uh, for example, like you guys uh, work in your labs on various like SOM lab, you do the destructive testing. Various jobs are there which involves laboratory job testings. Software companies. Now you might be thinking like software companies with software companies like Infosys, Cognizant, all that. No, it's not like that. The software companies are those companies. For example, you design a product in SolidWorks, right? Now the software companies would like you to do the back end part of that product. For example, I have to do a CFD simulation, right? What will I do? I'll open a CFD software, for example, Star CCM Plus or OpenFOAM, and I'll just put my design over there, and we will have a particular simulation performed over it. Now, simulation is done by the software. Now, actually, what code does the software use in order to reach over there? The back end part of it. For example, you are making solvers, 2D solvers. The code, all the equations like Navier-Stokes equations, continuity equations, momentum equations, which are involved in CFD, you will have to code them, and then only you will be able to get jobs into these particular sectors. Software companies won't be giving you jobs on your proficiency of the software, like how good you are at software. No, you won't be getting a job regarding that. If you are very good with softwares, you will be getting a job in the design sector, not in the software companies. But if you are very good in coding in the sense, if you are very good in doing mathematics with the help of code with any particular language, you will be able to land a job in software companies. Now the second uh, sector is the plant jobs, field jobs, as some people say. Now, it is a very wide sector, right? People who are preparing for GATE who need to go into BHEL, GAIL, SAIL, ONGC, they will also be working on these type of jobs, right? So, right now, you won't be knowing the possibilities that are in this sector. The people with white helmets, people say, yeah, they are engineers. This is that kind of job. You will have to do calculations over there. You will have to do perform your thermodynamics, fluid mechanics on daily basis, and to the very least your basic mathematics. Now this has a wide variety of scope. It is one of the most wide variety. BOE is boiler operation engineer. Anyone who wants to go into thermal sector, into the power plant sector or the energy sector, BOE is a very good option. But regarding BOE, you have to first get 2 years of experience as an engineer working on boilers, of maintenance of boilers, either manufacturing of boilers or operation of boilers. After that, you'll be able to secure a BOE. You have to perform you have to do an exam. After clearing that exam, you'll be given a degree of BOE. Okay, and BOE is a very well respected job also. You'll have to operate the boilers. Energy audit. Energy audit is also one of the new fields. I will not say new field, but one of the most rising fields in these days. For energy audit also, you'll have by BEE. There's an exam. You have to clear that exam. You'll get an energy audit job. Vibration analyst. Now, many of you people might be interested in SOM, right, or design of machine, kinematics of machine, but half of them think only the jobs are in the designing sector. That is not the case. If you are into plant-based job or any consultancies, vibration analyst also, you'll have to undergo an exam for this also. Now, the vibration analyst job is a very promising field also. In vibration analyst, you'll not only be present on the field, but you'll also be doing things back in the software part also, and also you'll be doing some calculations or some experimentation in the labs also, right? As a vibration analyst, you have to judge like if I do a welding on a particular, if I have a welding job, and if there are machines placed over there, you have to analyze the vibrations. These are more into maintenance related job. Okay. Then comes the welding inspector. Same thing for the welding inspector also, you'll have to clear an exam. But the thing is, in welding inspector, any particular new site that is being constructed, even in civil also, they require a welding inspector. You have to perform various tests. The NDT, there is a good field also, this non-destructive testing. In non-destructive testing, you perform things like X-ray analysis, and the DP test, dye penetration test, and ultrasonic test. There are various field in this. NDT analyst is the vibration analyst and the welding inspector. These two are quite not related, I would say, but these come under NDT sector umbrella. Okay. Piping engineer. Now, piping engineer, if you go into oil and gas field, which is one of the most highest paying jobs, uh, your daily job would be, designing pipe like this. Why there are loops? If you see any, you know, steam pipes, after a few distance they give expansion loops. Why do they have to do that? If there are bends over there, how much will be the loss, friction loss, pipe bend loss? So you'll have to calculate all those things. Those come under the piping engineer. Maintenance engineer, utility engineer. Now maintenance engineer is the job which will be requiring your each and every subject. Why is it that you have to deal with various machines? Now, machines are not like you have very big 66777 floor big machines. A small pump is a machine, right? Now you have to know how the pump works, how the compressor works, what are the working pressures, what is the difference between flow, velocity, and pressure. So for maintenance engineer, you also need to know the material science because you have to analyze if the pipe is getting rusted, how much time will it take to deteriorate the material, if the fluid inside is acidic material or a basic material, right? So you'll have to know the water chemistry for this. So maintenance engineer is a very good job. Uh, it will require each and every subject that you are studying right now. Reliability engineering and maintenance engineering can come very handy. Okay, so maintenance engineer also there are various subjects that you can get involved in. Like I said, reliability engineering, and also there are subjects which will also I don't know if you guys have studied the bathtub curve and all those. We were taught those things, the TPM, all those things. Utility engineer. Utility engineer also involves the operation of compressors, right? The boilers, anything, the water, anything that a company requires as utility. Now, what is utility for a industry, right? If I am processing edible oil, for example, if I'm processing edible oil, everything that is involved in the refining of edible oil will come under utility. The electricity will come under utility. The water will come under utility. The raw material, sorry, and the steam will come under utility. The machines that are required to pump the fluid, that will come under utility. So basically, anything that will aid the process in order to get it done will come under utility. So you have to deal with all those things. Production engineer, yes, you will have to look into the things like in the mm, iron and steel industries, the production, the plastic manufacturing companies, they will also have production engineers. You'll have to look into the various subjects over there. Okay, so this all comes as the core jobs that many of us are taught to be going towards that, right? The core jobs. Now, if we come into the core industry, right now, see, there's a very difference. You might be puzzled in this, but if you get the difference, you will exactly know the right terminology to be used. Like the core industry is also something that requires mechanical engineers, but there are jobs which are not purely core, like sales and marketing. technical sales. Now, in sales, why do we require a mechanical engineer? The thing is, if I need to sell a valve, every one of you must be knowing a valve. No, let us leave the valve. For example, I am a technical sales engineer and I need to sell uh, a pump, right? So for the pump part, what we need to do, we need to have a technical person who would be selling this particular thing. Now, if I'm a person who is coming from a non-technical background, I won't be able to tell him that the pump head is this much, this much is energy consumed by the pump, and this much is the flow given by the pump. This much is pressure given by the pump. Now, I won't be able to give you these terms, right? So for that, mechanical engineer is required. Not only in sales also, but also in marketing, because you cannot go to an industry and sell directly. These are not small products like toothpaste and all those things. You need to have a very strong technical background in order to know these things. But this won't be a very core job, you see. Now, why won't it be a core job? Because you won't be using those mathematics and all those derivations that you might have studied over there. But you, it is a very prerequisite and a very mandatory thing that you should be knowing this stuff. Otherwise, you won't be able to do. So this is a core industry, but not a core job. Okay, but don't get mixed up with that. Then this is not core. You require mechanical skills for it. Supply chain management. Now, what exactly is supply chain management? Buying, selling, and all the process in between the inventory and the store management. This also requires mechanical engineers. Why is that? Because you also have studied some projects, subjects like operation research and all those things, right? So this is a very common thing that people don't understand, is that why does a mechanical engineer uh, require to have the knowledge of store operations or inventory management. These are the things that not only in a single industry but many industries require this thing. So like if you are having a very good command over supply chain management, then even companies like Amazon and all those things, and not Google, Amazon, Snapdeal, Flipkart, they will be able to hire you guys. So this is the difference between a core industry and a core job, right? So this is the one of the common question that all the people ask, like what are the expectations from college graduates that the industry keeps. So these are not the de facto things that industry is asking, but as per my experience that I have been in the industry, I got to know that yeah, if you guys have these much of things with you, you'll land up with a job, very good job, I would say. Your fundamentals should be strong. You have to get the basics right from when you are studying the books, right from the first chapter, which people tend to ignore a lot. You have to know the fundamentals. Only then you'll be able to solve big problems, right? If I don't know how to solve Bernoulli's equation, how will I be able to do big calculations when I'll be posted with a project or things? So you have to get the fundamentals right. Only then people will know, yes, if you get the fundamentals right, big things, even the industry can teach you. Be curious, be like a child, ask a reason for everything. Why is this? Why is that? If we are using only 5% of solution, why are we using 5% of solution? Why not 10%? So if you are curious about things, the industry people also like this thing. They know that now you are interested towards your job, so they will teach you a lot. Okay, now be technical with your approach. Please be technical in your approach. Every time if they ask for suggestions from you, or if they ask for any small minute details, you please be very specific. You are engineers, are qualified engineers. That's why they have hired you for this job. So if you won't be giving them technical answers, then what's the use? You should be technical with your approach. Even if they ask that why is the tank not filling in 10 minutes, why not 15 minutes? The answer should not be like that. The wall was half closed, the wall is fully open. You should be able to tell the viscosity is this much, so this much is the volume of the tank. It takes this much of time to fill it. So you must be technical with your approach. And the most important is the application. Industry doesn't care if you remember formulas by heart. Okay, they won't be giving you a design of, for example, if I was to design Burj Khalifa, the people won't be expecting from me that I know the formulas by heart. And even if I do remember, they won't even trust me for that. If I have to design Bugatti Chiron, they won't be saying he remembers the drag coefficient formulas and all those formulas by heart. You can see those formulas from the book, you know. The thing is that you should know the fundamentals and you should know where to look when you get this problem. For example, if I give you that I have to design a wing for a F1 car, so you should know that I should be able to know the CFD part for this and a bit of material science part. Let us leave aside the material, but the aerodynamics basics you should know. If you know this stuff, yes, then you can look into the books where do you have to look and where do you need to get the formulas. Okay. Now the industry demands, and these are also same things, the expectation and the industry demands. You should be having the right skill set. Uh, Now, the misconception that students are having is that software will, if I'm having this much software knowledge, if I'm having a certification, if I'm having diploma in this particular thing, if I'm having a degree in this particular thing, I'll be able to get a job. That will help you land up a job, but that solely won't be the right thing that would be giving you the job. Okay. So not only softwares, you should know softwares, and you should prove this that you know the softwares by telling them that you have done this project. If you write in your CV that I'm knowing SolidWorks, and if another guy shows me a project that I have designed this particular car using SolidWorks, so I know that this person can back his thing by a project, right? So you need to have projects. Willingness to learn. Now, willingness to learn is like you have to be desperate to learn, right? If you are not showing any interest in learning, then even they would be like, okay, this is just a simple 9 to 5 job for him, so don't waste your time on him. So you should be willingness to learn. Like I said, you should be curious. You should be willing to learn. Okay. Extracurricular activities. Yes, any thing that you learn in the class, you should be able to do that in practical also. Get involved in college events which involve these projects. Do your side projects also. Do participate in competitions. This Baha, SAE, Formula, SAE, these are very good things that can get you started for that. Adaptability. You have to adapt to different situations. The situations won't be like that. These much questions are coming in the exams. You have to do that. Anything can come at any time. You have to be patient. You have to use your mind very coolly, and you have to be adaptable to various problems. Now, I'll be giving you a simple tips if you want to land a job in as a design engineer. First of all, you should be knowing engineering, graphics, design, and drawing. These are the de facto things that you should be knowing. You know, the basic fundamentals, as I said. Command on at least one software. If you know at least one software, all the other softwares you'll be able to grasp very easily. Like if someone says that in this industry Creo is used, and in another industry SolidWorks is used, and in third industry AutoCAD is used. Now you don't have to learn each and every software. You just learn one software. If you know SolidWorks, you can do Creo very easily. Just there are simple, the UI design is different, right? And some also various functions also, but you can do those very easily. 2D drawings, physics, design of machine, fundamental maths. Uh, Design engineers should know all these things, right? You have to be creative for the approach. The approach needs to be very creative. Now, people only think that if I can extrude a 2D model, I am a design engineer. That is not the case. You should be knowing the solid modeling, the plastic design, the sheet metal design, surface modeling, geometric deviations and tolerances, okay, dimensions and tolerances, the body in white structures, jigs and fixtures. All these should be known by a design engineer. Only then he can do a very good design. Also, if you are doing design projects, try to construct each and every part and then assemble it. Don't make the assembly itself as a whole part. If you make different parts and then do a different and then make a assembly, then it is good. If you design the assembly itself as a part model, that won't be functional, that won't be good. And also you need to have a little bit knowledge of manufacturing also. Only then you can, the GD&T part will play a very big role in that. If you design a very critical component which cannot be manufactured, then that is of no good use. For plant engineer, if you guys also are interested in very the what do you say that in gate exam based jobs like BHEL, GAIL, ONGC, then you most probably will be posted as a plant engineer or a process engineer over there. You need to have strong fundamentals in thermodynamics and fluid mechanics. Fluid machinery is a must. Why is fluid machinery a must? Uh, in every industry, fluid flows, right? Pumps, compressors. These are two things that any industry thrives upon. So you need to have a good grasp over the fluid machinery, because it not only will it make your job easy, but it will also make your job a very fruitful one. You should have good mathematical skills. You should be good with conversions, because sometimes people say the vacuum is this much torr. One will say you in torr, one will say in Pascal, one will say in bar. So you should be knowing the conversions, because over there you need to do the conversions very quickly. We are dealing with high pressure machines over there, so you should be doing the things very clearly over there, right? Now comes the, yeah, strict emphasis on your training. The training, you know whenever you are going into your training in your third year, second year, people always have this particular mindset industry that if you are doing your training very good, that is without pay, right? So you'll also be able to perform very good in the industries when you are given a pay, because industrial training is your first exposure to the industry, right? So if you are good in that, yes, they'll obviously hire you. Eds, blueprints, they should be easy to read for you. MS Office, yes, it will play a very crucial role. The Word, you should know how to use Word, and Excel is a must. Six Sigma, Kaizen, 5S, Gemba, Lean. If you know this stuff, it is very good. It's not a mandatory thing that you should know, but yeah, it will help you a lot in interviews also. Plus, it will also help you give an edge over other candidates. Minitab is a software which is used for optimization. If you guys are into optimization, yes, you should use Minitab. Power plant, manufacturing sector, process industries all require this particular stuff. Okay, so your role, right? So what to focus on, what not to focus on right now when you are in college. Okay, so things to work while you are in university, because that is the time when you have free time. Also, you have to do your projects. Also, you have to do your assignments. Also, but you also have to take out time so that that makes you more employable. Only getting good grades won't land you up with a very good job. You have to perform things which are out of the box, also out of the curriculum also, that would help you while you are applying for jobs. That this will give you an edge over other candidates also. Academics, as I said, nothing can beat the textbook study. You have to study a lot. You have to get your basics right. Okay, projects. Now projects are the things that would give you an edge. How? These are the things that you, if you want to boast about yourself, right? Like mm, that I have done this particular thing, I have done that particular thing. that you cannot say that I know the software and I have that done thing. You need to have the software knowledge also. And how can you showcase that particular, how can you show your expertise in that particular thing, is only by doing projects. If you do projects, you can showcase the projects that I have, sir, designed this particular thing, I have done analysis on this thing, and I've got this result. This result is better. Why? Because of the particular things. So then, so you don't need to explain that you know the software. They will automatically come to know that you know the software. How? And you can also prove your expertise by showing the project. Now you don't have to say that, sir, I know the software and I am very good at it. Your project has already spoken about it. The project that you have shown in front of them, that will speak for itself, right? So do focus on projects. Industrial training. Now, industrial training is a very great thing to get into, right? It will train you, it will give you the insight of how the industry works. It is basically, it's just like an experience that you are working in an industry. You should seriously go for that. Many people, it's a very common, you know, thought process in India that I will go for the first 1 week and I'll go in the last 2 days just to get the certificate. That is totally a very wrong habit, and you should not do it. You should go in the industry. You should ask ample amount of questions. Just asking questions can also land you jobs. If you ask them a lot of questions, they'll definitely get to know that the person is interested in doing the job and is also interested in working here. So that will give a very good impression of yours over there. So you should go to the industry, you should train yourself, and you should ask ample amount of questions. You should give suggestions in a very humble way, but also uh, do not try to have a very bad relationship with them. Do not leave the company, or do not you know come from the training by giving a very bad image of yourself. Technical activities, as I said, the more you get yourself involved in those activities, the more are the chances that you will be able to do those theoretical things in practice. The more practical approach you'll have, you'll get to know more about things. So in the industry also, it will help you a lot. Sometimes in the interviews also, they give you very real life situations, so the textbook knowledge won't be helping you in that. In that time, only the practical thing that you have done will help you. Competitions, if you are really serious about your passions, yes, competitions should help you a lot. Why? Because what will it show the industry? It will show that you have done something extra out of your curriculum in order to prove yourself in that particular field, or to just be in that field. You know how to be good at. Um, if you go into any race, right? I'm an automobile person, so I'll speak about automobile. If you are going into a competition that will involve you, that will either get you a podium win, or even if you participate in that, how will you have an edge? That will show that the person has involved himself in day and night struggles also. He has known how to work in a team. uh, he does know leadership qualities. He does have practical skills also. So competitions will help you a lot. Final is the publication part. If you write a research paper at bachelor level, it will surely give you an edge, and it will help you a lot. Even if you go to LinkedIn also, your profile is boosted a lot if you have publications in your name. And LinkedIn is one of the best platforms that will uh, help you land up a job, or have a very good, what you'll say, an industrial professional image of yours. Okay, so I'll prefer that you should go into this research paper part also. Other than that, yeah, I'll give you some project ideas. Okay, so if you are a design engineer, if you want to become a design engineer, just sketching concept cars won't help you. See, the major misconception that the people are having is that if I know how to use this particular software, they will hire me as a lead designer, or they'll directly hire me to design a car. That is a totally wrong image of of that industry in your mind. Even if you are involved in one of the best companies and doing one of the best design jobs, you'll have to design a component only. You won't be designing the whole car as. So in order to show your expertise regarding the software also and your thought process behind it, you need to have some projects. For example, many people just do the modeling part. If you do the sheet metal design also, not the sheet metal design that you have designed a CPU cabinet, yes, that is good for the basics, but in order to show that in a project you have to do something critical, you have to do something that is outside the box. So things like this, design of car hoods, design of door panels, and all those cabinets also, so these will help you a lot. Okay, you can do this. You can also design various parts and assemble as a component. uh, as I said earlier also, people just design the whole assembly itself. If you get to design the parts, you'll actually uh, be more excited about the project also, and also get yourself more involved in the project. Now, these are a bit advanced projects, but yeah, if you do them, you will have a very great profile. CFD is a very common thing nowadays, and it's one of the promising fields also in the future, because models are getting very expensive to get trained in wind tunnels and all. So CFD is a very good tool in order to bridge the gap. Okay, CFD is used for combustion and emission characterization. It is used for creating solvers. Sorry, I'm sorry. You can create solvers for CFD by coding. Over here, if you see this thing over here, right? This particular analysis is done, CFD analysis is done in a software that is open form. Okay, so you only know how to operate the software over here in this project. But if you want to actually know the science that is used behind it, what is the actual equations that are being used, what is the mathematics that is being done over there, you have to code. And what you will code in that, you will be coding the same equations. You will be making calculators that will be performing those equations, mathematical equations. Okay, so by creating those solvers, yes, you'll have this the backend part also of the software. So this doing this coding will help you in getting those software jobs that I talked about earlier. These are also the same things, flow simulations. Yeah, this is one very great thing that you can do simulation of existing models on the internet. There are various models on the internet and various free sites. You can just download them if you want to, get a better hand at the software and do various unlimited amount of analysis or anything that you would like to be doing. You should do that, because more you will practice, the more you learn. Thank you. uh, if you have any questions, you can ask me any questions now. uh, Feel free to contact me. You can contact me on mail. This is my mail id, bisht.rajat119@gmail.com. You can also connect me on with me on LinkedIn. I'm very active on LinkedIn. So anytime you have any doubt, or if you want to know anything about the industry, you can ask me over there. Okay. I'll be giving this slide also to the organizers of this, so they can post it later. Okay. Thank you. You can.
So I want to know, can you tell me about what were your interview process for Adani and Sanmar, which you have faced?
Yes. So in Adani, first there was a test. It was a short test. The time duration is very less for a Adani interview, but the questions are very easy. Relatively, I would say very easy. It comprises both of this your technical as well as aptitude. So after that, I was selected for the interview. There was no GD process in this. In the interview, mm, basically the questions that they asked were of this from my training and my projects. Since I had done my training, my major industrial training from ICAT, so the questions were from there only. A few basic questions also from material science. After that, they asked 2 to 3 questions on my projects and nothing else than that. It was a relatively easy interview, I would say. For Sanmar, yes, it was a very tough procedure for Sanmar. First, there was a technical test, and the test was quite difficult, I would say. After the test, I was selected for the group discussion. It was a pool campus, so with us, 20 more colleges were also participating. So in GD process, it was a batch of 20, and only 3 students from my university were in my group, and all others were from different group. So after GD topic was also quite easy. It was industrial revolution and all this stuff. After that, I was selected for the HR interview. So in HR interview, they ask you typical HR questions which you can prepare from the internet also. After HR interview, it was the technical one. Yeah, it was the first technical round. It was a good technical questions. They were, for example, they they will ask you about your interests. What are your interests? What are your subject preferences? After that, they will be asking you questions, relatively easy, and after that, the questions keep on getting tough. The toughest question that was asked in my interview was to derive continuity equation. After that, I had been selected for the final interview, which was the technical two. It was taken by the managing director of the company itself. So a few first 10 minutes, for the first 5 minutes, just were basic questions, very easy. He also asked about my family and all those typical stuff. And after that, he gave me two real life situations. 2 questions were from fluid machinery earlier, and after that, he gave me two real life problems, and I had to solve those real life problems in order to get the answer. There was no particular value given to me or a particular answer that he wanted to get. It was basically how could I face the situation if I was given a question. So, my questions were on dam, uh, the velocity of the water if the uh, dam gate is opened at 2 different levels. So he asked me how will you use it, what will be the approach. So I solved it and I was selected for the company.
Okay, thank you. So you even talked about the training. Can you tell me what your training was like and what you were taught in it?
Which training? My ICAT or HRTP one?
I get one.
ICAT training. So basically, when we applied for ICAT, Dr. Dhananjay R. Mishra, he had suggested our names for ICAT. So we had provided our mark sheets and CV, and the interview. There was no interview for the training, but the process was quite tedious. So in the process, I think it took almost 2 months to get a confirmation from there. After that, we were called in the main campus only. There are two campuses of ICAT, Unit 1 and Unit 2. In the ICAT Center 2, it's mostly track testing. So we were selected, me and Abhay Bajaj, my fellow colleague, we were selected for ICAT. He was posted in the electrical department, I was posted in ETC. So basically, my daily, I would say a job, my daily job over there was to just learn. Uh, my typical office was like a dynamometer. I was behind a screen. There's a glass over here, and after the glass, there's a dynamometer and engines. So my basic, this. input from there was I had to collect the data, not collect as in I was doing the calculations or doing that. No, I was just to there to learn how the emission analyzers works, right? Like there are various technologies. I was introduced to FTIR, Fourier transformation, infrared spectroscopy, then for gas analysis, and also for if you opacimeters for the density or the opaqueness of the smoke, how visible it is. So all these things which are required for the homologation service. Homologation is all the tests that are needed to be done by a car in order to enter the market, right? If I were to say that I'm a car manufacturer, for example, say I am Honda. If I want to introduce a new car into the industry, I need to get a government approval. So that government approval is either provided by ARAI or ICAT. So I was in ICAT. So my main job, right, during that time was with Volvo Eicher. They were testing their new BS6 engine, the first for commercial vehicles, CNG BS6 engine. So I was involved with them. I was learning regarding all the emission test cycles, what all they are doing, what all the government norms are, what are these norms made upon. So these were the basic things that I was learning. And the same thing I was also asked in the interview, my Adani interview also.
Okay, thank you, sir.
Okay, welcome.
Sir, I'm having a question. As my interest is in aerospace industry, what kind of industrial training I'd be doing and in which industry?
See, if you are having an interest in aerospace industry, so there either you can go into any aerospace sector like HAL, okay, GKN is also a very good manufacturer in aerospace sector, Boeing, all these big names you can get yourself into. But if you want to get into the actual, the jobs in for the job scenario part, any industry that would be training you in CFD analysis, right? Because aerodynamics is nothing but CFD. Don't get me wrong on that, or mixed up for the both things. But in CFD, what you will do is you'll be given small projects, right? Any aerospace manufacturer or any wing manufacturer, or even if the automotive sector, if you get to work in the automotive sector also, try to get your department in the this CFD analysis part. Because if you will get more involved in the CFD and more involved in aerodynamics, you'll have a better profile to go towards the aerospace sector. Okay.
Thank you so much.
Okay, welcome.
So I even want to know, can you tell me how the resume or portfolio should be created or made for a particular design or automobile industry?
See, if you want to go specifically in automobile and that too in a design field, it's better to have projects. See, the simple thing is if you are having projects and all this, many people tend to write hobbies and all those things on resume, which I don't feel is okay. But yeah, if you don't have anything else, you can include them. I'm not saying no, but I don't prefer them. For see, for this thing, either if you're applying in online also, you can try to attach your LinkedIn profile, and on LinkedIn profile you can also attach. There are also sites like where you can add your CAD projects. I'm forgetting the name right now. You can also add the link to that. Now, if you're actually making a CV or a resume for that, the first thing that you should have at least 2 to 3 projects. Okay, that should not be indicating that you have learned the software or you are good at software. That should be more focusing on what the problem you have solved in the design, what actual was the problem statement, not in this much detail. Like if you have to design this car for this purpose, like I have designed simply writing a designed an all terrain vehicle car for this much for overcoming this obstacle. So now they are knowing your project detail also, and at the same time they are knowing the problem statement also, the obstacle being the problem statement, and the solution for that problem is the design that you have made. So you are telling them that you have made a very good thing, right? And how can you make that good thing? That is obviously through a software, right? So you don't need to tell them that I'm knowing this much software, right? Like I'm knowing SolidWorks or I'm either knowing Creo or anything else. They will automatically get to know that you know this thing, right? So try to involve these type of projects. Secondly, if you have training in these things, very well done. And you might have done courses also, right, for learning the softwares. So try to add those certifications in that CV. Okay, though your projects and training will surely land you up with the job, but these things will add a boost up to your job, I'll say.
Okay, thank you so much.
Okay, okay. Anyone else? No one?
So, my friend in the chat box has asked, what kind of project should we do?
Yeah, it's a very good question. See, projects, right? You should do these kind of projects which not only solve the problem but are also actually relevant to the industry, right? Many people are there who just do the project for the sake of completion. uh, if you actually do problems, like if I was to go into design sector, right? So in automobile sector there are very few engineers who can design door panels, not the outside door panels. Surface modeling, anyone can do that. The inside of the door panel should be designed. Okay, you can work on that. You should work on softwares like radios, which tells the crash worthiness. These kind of projects, yes, you would have to look for them. You should also be doing projects which like in CFD, if you're actually coding solvers. Coding solvers is the thing which very less engineers do. All of them think that they are knowing the software, any CFD analysis software, and they think they know the CFD. But that is not the case. For actual meaning of the CFD, you have to look beyond the part which is actually solving the problems. So you need to know the equations that solve those problems, right? And in order to solve those problems, you have to code those equations in order to get the answers. So that will tell that you not only know how to solve the problem, but also actually know the mathematics that is being involved behind it, right? So try to do these kind of projects. Yes, you can also do projects which you have to make, but yeah, any project that involves research, tedious research, go for it. Okay.
Thank you
I
so much.
don't think there are any questions now, or are they? In chat box also, I cannot see any. Okay, I think you should wind it up.
Thank you so much, sir. On behalf of SE JUT, I would like to say thank you so much for great words and your views and even your time. Thank you so much.
Thank you. It has indeed been an honor to be invited by you guys. You guys have asked very interesting questions. Thank you. Please keep your curiosity this much high only, and all the best for the future. Thank you.